All right, hi folks. This is Larry Mussolino. I wanted to do a few more examples to help you with the Module 1 assignment. And so there were a few other examples that I thought would be useful to go through together. And let's take a look at this one. This is number 11. It says the figure to the right is the distance time graph for a muscle car accelerating from a standstill. Use the information in the figure to answer these parts. And they're also giving us a table with the XY coordinates of each one of these points labeled Q1, Q2, Q3, Q4, and there's another point labeled P. All right, let's see the first one. It says the slope of the secant line PQ2. Well, PQ2, let me draw this graph here. So Q2 is here somewhere, and P is up here. Well, when they say secant line means the straight line connecting these 2 points. So I'm going to imagine a straight line connecting these 2 points. I'm not going to be going on this red portion of the curve because that's the curved portion. I want a straight line connecting P and Q2. Well, really, they're asking me for the slope of that straight line. So if I take point Q2, which is 11.9, 292, and take point P, which is 2650, I can use the slope formula. So I'm going to label these points as x1, y1, x2, y2. I'll use the slope formula now. So slope m is y2 minus y1 over x2 minus x1. So it's going to be 658 minus 292 over 20 subtract 11.9. And if you work this out on a calculator, it says round to the nearest integer. Integer means whole number. You'll get the answer 44. So the slope of this blue line is 44. All right, well, they're going to ask us to do that for P, the line connecting P and Q3. Then they're going to ask me for the line connecting P and Q4. And then they're going to ask me, what is the order of the slopes of these secant lines from least to greatest? You might need to calculate PQ1 also to help answer that. Well, you'll probably see the slopes go in order, PQ for Q1, Q2, Q3, Q4. All right, then let me go down to the last question here. It says, estimate the speed at point P. Well, if you notice from this diagram, the speed at point P is really, you could think of it as the slope of a tangent line at point P. And I can see that point P is very close to points Q3 and Q4. And so it would be reasonable to use the same slope for Q3 and Q4 as I do for the speed at point P. So speed is distance over time. And so really I can think of this as a slope calculation. And really what we're doing here is we're finding the instantaneous velocity, the instantaneous speed at point P. All right, let's go to another example. How about, there's one where, yeah, let's do this one. It says the table here is velocity of an object each second as it moves along a track for 10 seconds. Estimate the distance traveled using 10 subintervals of length 1. And they're asking me to use left endpoints and then right endpoints. All right, well, let me kind of think about this in terms of left and right endpoints. And so what I could do here is draw a little diagram. Actually, I don't really have to draw a diagram. If they say left endpoints, they mean for me to start here with the left endpoint for portion 1, And then they're going to ask me to look at the left endpoint for every one of these intervals. Part B is going to ask me to use the right endpoint. And so maybe it is good to do a quick diagram. I think it'll be good to visually see the areas that we're going to try to estimate here. So let me form this as velocity versus time. And do you notice these values increase, but then decrease? So it looks like they go up to 36 as a max and then start decreasing. So what I'm going to do here is let me label 0, 1, 2, 3, 4, 5, 6, etc. Of course, I would go all the way out to 10. All right, and if I was to draw the velocity here, it's 0 to begin with, then it goes up to 5, then it goes up to 11, then 17, then 24, 36 is the max, then it starts coming down, and so on. I won't graph this precisely, but I just want to get a sense. 8, 2, and 0. All right, well, let's say this is the graph. And what they're asking me to do is use left endpoints. So let me draw some rectangles. And when I draw these rectangles, I'm going to use the left endpoint to determine the height of the rectangle. So let me start here. I'm going to call this rectangle A, rectangle B, C, D, and so on. Well, for rectangle B, I'm going to use this height because they told me use the left endpoint. So for rectangle B, this blue dot would be the left endpoint. For rectangle C, I'm going to be using this height, and D is this height, and E is this height. Now for rectangle A, the height really is 0. So what I'm going to do for the left endpoints is add up these areas of these rectangles. But now the width is 1, so really what I just need is the height. And for rectangle B, the height here is 5. Rectangle C, it's 11. Then 17, then 24, and so on. And when I get out here to rectangle 9, I'm going to be drawing a rectangle that looks like this, and rectangle 9 has a height of 2. So if I was to calculate these areas, it would be for rectangle A is 0. The area for rectangle B is 5. So this is rectangle A, B, C, 11, 17, and so on. And if you add these numbers up, I'm going to end up with adding a 2 here, because 2 will be the last rectangle. And if you add these together, you get 148. All right, what about right endpoints? Well, it turns out if you use the right endpoint, you're really going to end up with a similar conclusion. Let me erase some of this, and we'll use right endpoints now. All right, well, right endpoint means when it comes to rectangle A, I'm going to use the right edge for the height. So rectangle A is going to have a height of 5. How about rectangle 2? Well, the right edge is 11, so the height is going to be 11. Rectangle 3 is a height of 17, so the height's going to be 17. And I'm going to keep going until I get to rectangle 10. The rectangle 10, if I use the right endpoint, the height is 0. So for right endpoints, I'm going to start with 5, plus 11, plus 17. I'm going to keep going, and I'm going to end up with a 0. But because both of these left and right endpoints ended up with a height of 0, I'm going to get the same answer here. Normally, you would not get the same answer, but in this case, we did, because it didn't matter whether you use the left or right endpoints, we'll end up with the same areas to be summed up. All right, let's do a different example where we don't have the same left and right endpoints like we did here. Let's go to number 15, maybe. Yeah, let's take a look at this one. So in this one, it says you're driving on a stretch of road with a speedometer, but no odometer. Odometer means measuring distance. And so it says to find out how long this road is, you record the car's velocity at 10-second intervals. Estimate the length of the road using left endpoints. Estimate the length of the road using right endpoints. All right, well, again, I could envision drawing a diagram here. And each the widths here are 10, right? 10 seconds, 20, 30, 40, and so on. So this is time in seconds. And we're going to go all the way out here to 120. All right, and let me just plot some of the velocities. At 0, the velocity is 0. At 10, it's 42. Then it goes down to 12. Then it goes up to 20, a little up to 27, and so on. Then down to 21, and so on. And so let's go ahead and so here is the velocity curve. Let's do part A where we use left endpoints. So let me draw a rectangle A, B, C, and so on. Well, if I use the left side of each of each interval, this rectangle A is going to be a height of 0. How about rectangle B? Well, if I use the left endpoint, this height is 42. And how about rectangle C? Rectangle C, the height is 12. Remember, we're using left endpoints. All right, well, let's do the area calculation then. For rectangle A, it's going to be a height of 0 times the width of 10. For rectangle B, it's a height of 42 times a width of 10. And then rectangle C is 12, height of 10. And I'm going to keep doing that. But when I get out here to 110 at 44, remember we're using left endpoints? So I would be using this height for the last rectangle. So I'm going to end up with 40. I'm going to end with 44 times 10. If you add these areas together, 3450 is the total area. All right, let's do part B, where we want to use right endpoints. So here is our diagram again, all the way out to 120. This point is 47. Now we're using right endpoints. And at 10, it was 42. And then it goes down to 12, and then back up to 27 and so on. All right, well, if I use right endpoints for rectangle A, I'm going to be using the right side of rectangle A, which is 42. For rectangle B, I'm going to be using the right side, which is a height of 12. And rectangle C, I'm going to be using 27. Oops. What about when I get here to the very right side of this curve? Well, the right endpoint is going to be 47. So I'm going to be using a 47 here for the height of this last rectangle. So when I go to calculate the area for right endpoints, it's for rectangle A, it's going to be 42 times 10 plus 12 times 10 plus 27 times 10 plus, and I'm going to come to the very end, and the last rectangle is going to have a height of 47 times 10. So this answer for the right endpoints is going to be different than the answer for the left endpoints. And if you add all of these together, you'll get 3920. Okay, you can put these numbers in a spreadsheet, by the way, and kind of automate this process if you wanted to. Another shortcut, by the way, is you could factor out a 10 from this sum and just do 10 times 42 plus 12 plus 27 plus dot, 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 plus 47. And that should, of course, still give you the same answer, 3920. Okay, give that a try. Let me know if if you have any questions on that, and hope this is helpful as you're working in the Module 1 homework.